Hello. In this session, we'll talk mainly about MS-DOS EXE file format. This MS-DOS executable format is the format generally used by Microsoft Disk Operating System to execute the programs. The most common executable file extension for MS-DOS is .exe. The structure of an MS-DOS exe is relatively simple, uh, which consists several sections that help the operating system to load and execute the program. Let us try to understand the breakdown of this format. So first element, first part of this format is DOS header. This DOS header is a 2 byte, so which contains information about magic number. The first 2 bytes of an EXE file. Generally, whenever we try to open an EXE in some proper editor which permits us to see contents of EXE, you will recognize that the first 2 bytes of an EXE file are having characters capital M, capital Z, which represents the ASCII characters M and Z. This signature used to identify the file as an EXE file, especially for DOS or a disk operating system. Now this MZ is named after Mark Zebowski, who was a Microsoft engineer, actually designed this format. This MZ header is followed by variety of fields that describe how the program will be loaded and executed. So which is as follows. DOS stub. After the MZ header, the DOS stub contains code that can run when the file is executed in DOS mode. It typically displays a message like, say, this program cannot run in DOS mode. If we execute that executable which cannot execute that program, then this stub comes into picture and initiates this message. This stub is very minimal and is usually just a small message, which I said before a while. This DOS stub is followed by an executable header, kind of like PE header in DOS MZ. After the DOS stub, the file contains an offset to the actual PE, that is portable and executable header, used mostly by Windows or other executable formats. This is the starting point where the DOS loader will transfer the control to the executable code. The PE header is more complex and is used in modern Windows executables, which we'll be talking probably in the next video. This executable header is followed by an optional relocatable table or relocation table. Now, older DOS executables always used to include relocation table, which allows the operating system to load the program at an address other than the one which is specified in the file. Now, this table is needed for the programs that may have been written for different memory layouts. And that's why we are saying that this is an optional one. Segment table contains the program code, data, and stack segments. So we know code segment contains actual instructions. Data segment holds variables and global data, whereas stack segment is used to manage function calls and local variables. This segment table helps operating system to load and map these segments correctly into the memory. Then after segment table, you will find there is a program code. After the headers and tables, the actual code of the program starts. The code section contains machine code instructions that the CPU would be executing. This program code would be followed by data and resources. Now your program may contain embedded data, resources, or the resources which may be needed during execution. For example, the graphics, some fonts, probably configuration data. Now, these sections are stored after always the code section. And again, the last one, footer, which again is an optional one. In some cases, an EXE may have a footer or additional data at the end. It could be like, for example, a signature or debug information. Now, this is format of an EXE file header, like which we before a while talked about. Now, if we have to consider these what exactly they contain, correct? So, as we stated, there would be a signature, character signature, 2 byte, which is a magic number generally is identified, and these are the actual structure elements of an EXE file format. And you can see various variables used, which are really pointing out that a file format structure. Now, like if we have to talk about this EXE format, which this format was widely used in 80s and probably early 90s. Later, this format evolved into the Windows PE format, Windows Portable and Executable format, which is generally used for more modern Windows applications. However, these old MS-DOS exe files are still occasionally used for retro computing or running older softwares. Now, there are few organizations still relying upon various older softwares too. Now, if we have to talk about execution flow, let us try to understand what exactly happens when you execute an executable. The execution flow of an MS-DOS exe involves series of steps which are taken by your operating system to load, to relocate, and execute the program. So what it does, it initiates the execution. Now, when you say initiate, the program begins when the user types the name of an exe at the command prompt. Now, when user executes that, your operating system DOS recognizes the file as an executable based on the MZ header. Then DOS loads this exe file into memory and begins execution. Now, what DOS loader does, the MS-DOS DOS loader is responsible now uh, for loading this exe into memory. So as it already read that MSZ header, it verifies that it is an executable. Then it reads the DOS stub, like the code after the MZ header, and executes the startup code if at all it is available. The loader allocates memory for the program which is loaded by you and loads it into an available memory space. The file might not be loaded at its original address due to the need for relocation if at all required. Now, as I stated, relocation may be needed. So that's why, like, if an exe file contains a relocation table, earlier was to be available in exe files, the DOS loader adjusts memory references in the program to account for the actual memory addresses where it is or where it was loaded. This relocation process modifies all addresses in the program, like your code, data that rely on a fixed memory addresses. Now, these segments are to be what we can say set up. These segments are to be set up. So, what MS-DOS exe files have? These MXE files generally are divided into segments, typically 64 KB in size, which may include code segment, data segment, and stack segment. Loader arranges these segments in memory based on the segmented file or segment table. Now, when it is done with the segment table, ultimately, with assumption that program is loaded in memory and any relocation information, necessary relocation information has been performed, DOS loader transfers control to the program starting point, typically entry point of your program. Now, this entry point is usually indicated by early entry point address or entry point address in the EXE header. The CPU then begins executing the program's machine code instructions with that entry point known earlier. Now, during execution, this program may perform any IO operations, like you may have read write from the screen or from keyboard. There would be some system services called like DOS interrupts, probably memory allocation routines via those interrupts, even file accesses via those interrupts, and it uses the stack to manage function calls and local variables. Now, how these interrupts are handled? Microsoft DOS provides a variety of interrupts for interacting with the systems, like which we like in Linux, we do call them as system calls. For example, like in COM file format, we saw that we used a interrupt 0x21. Now, this interrupt is used to call DOS functions like reading from a file, printing to the screen, and so on. Now, the program triggers these interrupts, and the operating system provides necessary services via interrupt service routines. And operating system executes those ISRs for the program. And actually, your program starts executing there. Now, once the execution is done, when program completes its execution or encounters an exit condition, the program explicitly calls a DOS function to exit and return the control back to the operating system. Now, when program exits and control returns to the DOS prompt, where the user is now permitted to enter further commands to run the programs. Now, while doing that, ultimately, any resources which were allocated by the program are released by DOS when the program terminates. Now, when we said that a relocation may be needed, relocation in MS-DOS EXE files refers to the process of adjusting memory addresses in executable code. Now, this was done to ensure that the program can be loaded into available memory location at runtime. This was important earlier when memory management was less flexible and programs often needed relocated or to be relocated when they were loaded in memory. Now, if we have to really understand why this was required, first reason was memory flexibility. In DOS, memory addresses were not fixed or predictable. Programs were often written with assumption that they will load at specific memory addresses. But the operating system could load them at different addresses depending upon what other programs or system data already loaded into the memory. Now, as it was permitting multiple programs to run at the same time, so each program needed to be loaded into separate memory areas to avoid conflicts. Now, if a program assumed a fixed memory address, it will overwrite another program's data or code when loaded into memory. And that is the reason why relocation was needed. Now, how relocation is done? Relocation permits an EXE to be loaded at any memory address rather than the predefined one. Now, to achieve this, EXE file may contain special information called as relocation table, which helps adjusting all memory addresses in the program at load time. Now, this relocation table is a section of a EXE file which lists all the places in the program, like considering data as well as code that uses memory addresses. Now, this relocation table used to contain offset values. Now, we know offsets are the addresses within the EXE file where references to memory addresses exist. And other part was addresses to be relocated. These are the values that indicate locations in the program code or data, which needs to be updated so as to reflect with new base address where the program would be loaded. So this relocation table usually helped to identify where in the code or data to apply necessary adjustments. Now, why to do or carry out this relocation process, MS-DOS loader loads an EXE file and performs like some steps like this. First of all, when the program is loaded, and while loading, it identifies that uh, the program can be loaded into any available memory address. Program will not necessarily be loaded at its original or predefined address given in the program. Now, loader can place it wherever space is available. So to do so, the DOS loader used to examine the relocation table in the EXE file. It looks for the memory addresses and offsets in the program which are needed to be modified based on where the program is loaded. Now, while achieving it, it has to adjust memory addresses or memory references. The loader adjusts all these addresses listed in the relocation table. For example, if program code references to a specific address, say 0x1000, but the program is actually loaded at 0x2000, the loader will add the difference like 0x2000 minus 0x1000, which results to 1000 to every such address in the program. Further, all segments will be updated. The loader applies the necessary adjustments to the instructions, that means additions or data references in the program. Now, this used to ensure that when program runs, all memory addresses point to the correct location in the memory. This MS-DOS EXE file format, in this EXE format, the relocation informs typically stored into two sections, which we talked about, relocation table and relocation records. Now, relocation table, as we stated earlier, list of all memory locations that needed to be changed. And relocation records are the entries. Each entry in this table corresponds to an memory reference in the program's code and or data. which needs to be adjusted. Further, it has to take help of segment table. Segments in MS-DOS-EXE are helpful to decide how relocation should happen. So what MS-DOS does, MS-DOS divides memory into segments. Like typically the size was 64 KB. Now these segments would be used for code, data, and stack. And the segment table was supposed to help the loader to understand how to arrange and reference different memory regions. So for that purpose, it used to make use of segment registers. Now this process enables more flexible memory management in MS-DOS. But again, like though we say this, there were some limitations of this MS-DOS EXE files too. These files only supported 16-bit memory addressing and always had to deal with limited memory space. For a while, 640 KB of RAM was typical scenario. This process, like the relocation process of MS-DOS was simpler than what you see currently the modern relocations. So this is about MS-DOS EXE file format.